So this 7.3 video is going over simplifying radical expressions, which we already spent quite a bit of time on in the 7.1 videos. So this is actually just a review to go over it. So you should have notes on the majority of this. The only thing that you might want to add to your notes is understanding how to find roots of negative numbers, practicing that a little bit more. Beyond that, we pretty much have covered everything in this section. So let's go started. Here's our example problems. So again, remember when it comes to simplifying a radical, first we want to take our numbers and rewrite it into prime factorization. So basically it's primes with their exponents. So if we do 192 and we factor that, that would be 2 and 96, and this would give us 2 and 48, which is equal to 6 times 8, and so this would be 2 times 3, and then we know 8 is basically 2 to the third power. So we can rewrite this as the square root of 2 to the 1, 2, 3, plus 3 more, so 6 power, times 3, x to the 11th, y to the 13th. Okay, and then we can go ahead. Remember, we're going to basically divide all the exponents by 2. The whole number goes on the outside of the radical, and the remainder goes on the inside. So 2 to the 6, 6 divided by 2 is 2 to the third, no remainder. 3 to the first, that's not going to divide. We're going to just be left with 3 to the first power there. X to the 11th, 11 divided by 2 is 5, so we have x to the 5th on the outside and x to the 1st on the inside of the radical. And then y to the 13th, we do 13 divided by 2, we get y to the 6th, and then y to the 1st, because there's a remainder of 1. And so that is kind of a review of what we have done before. Now, remember, with an odd root that's a negative, that actually means that simplifies to a negative. So right away we can go ahead and just, I'm going to say my final answer is going to be down here. We can put a negative in front of it. So remember 32. So we're looking at the cube root, and we're going to go to the negative cube root. 32 is equal to 2 to the 5th power. We got x to the 5th and y to the 14th. So let's go ahead and divide our exponents by 3. 5 divided by 3 is going to give us 2 to the first power, and we're going to have a remainder of 2. So we have 2 squared inside of the radical. Again, we have x to the 5th, so 5 divided by 3 is going to give us 1, so x to the first power, and we have a remainder of 2, so x squared inside of the radical. 14 for y to the 14th, 14 divided by 3 is equal to 4, so we have y to the 4th power, and then a remainder of 2, so we have y squared on the inside. So this basically can simplify to negative 2xy to the 4th times the cube root of 4x squared y squared. Okay, now this also goes into the whole thing of if it's an even root and it's a negative, this means an imaginary number. And since we haven't covered imaginary numbers yet, that is one that we can't simplify. So this one does not simplify until we actually cover what an imaginary number is in one of our next sections that we're looking at. All right, so here's another example of problems where we want to simplify. So remember, we can rewrite this as 2 square roots of 100 times 3 divided by 30. So that's going to give us, we know the square root of 100, so that gives us the square root of, 2 times the square root of 100 is 10. Square root of 3 has to stay inside. Divided by 30, so this gives 20 square roots of 3 over 30. Reduce our fraction by dividing by 10, so this gives us 2 square roots of 3 over 3. All right, now with fourth root on this one, so we're looking at the fourth root of 2 to the 5th, that's what 32 is equal to, a to the 10th, b to the 19th. So again, remember, this means we're going to divide by 4. So we have 2 to the first power on the outside because 4 goes into 5 one whole time with a remainder of 1. So 2 to the first on inside of the fourth root. And then we have a to the 10th. So 10 divided by 4 is 2. So we have a squared with a remainder of 2. So we have a squared inside of the radical. And then b to the 19th. 19 divided by 4 is 4 with a remainder of 3. So 3 goes, b to the third goes inside of the radical. And that would be our answer. Okay, so essentially, rules with negatives and roots. You cannot take the even root of a negative number and get a real solution. So until we learn about imaginary numbers, that's pretty much it for us. You can take the odd root of a negative number and get a real solution, and it is always negative. All right, so here's an example problem again, kind of a review over what we did in our Pythagorean theorem section, where we want to be able to solve for x in this. So we're going to go ahead and set up our Pythagorean theorem. So we got x minus 2 squared plus x squared is equal to 10 squared. So we go ahead and we gotta basically multiply this out. Remember, it's a perfect square trinomial, so it's the first term squared minus 2 times the second term times the first term, so minus 4x, and then plus the last term squared, so 4 plus x squared is equal to 100. We got to solve this quadratic, so we're going to combine like terms and subtract the 100 over. So that gives us 2 minus 4x squared minus 696, is equal to 0. For simplification purpose, we're going to go ahead and divide out the common factor of 2. So we get x squared minus 2x minus 48 is equal to 0. So now we're looking at factors of negative 48 that are going to add up to negative 2. That would be negative 8 and 6. So we got x minus 8 times x plus 6 is equal to 0. Then we use our zero product property, and we set each factor equal to 0. And so we get x is equal to 8 or x is equal to negative 6. Now remember, this is talking about a side length of a triangle. So it's impossible to have a length that is negative 6. So that one doesn't count, and our answer is x equals 8. All right, so here's another one where we can use the Pythagorean theorem. So we have 8 squared plus 10 squared is equal to x squared. So in this case, we get to work on solving, simplifying this, because we got to take the square root. We get to work on simplifying a square root. So we got 64 plus 100, which gives us 164 is equal to x squared, which means x is going to equal the square root of 164. So let's work on rewriting 164 in terms of its primes. So I know 4 goes into 164 41 times, which is going to give me 2 times 2. So basically it's 2 squared times 41, because 41 is a prime number. So we've got the square root of 2 squared times 41, which is going to simplify to 2 square roots of 41. Okay, so then we got this problem here. We're going to make the Eiffel Tower into the Leaning Tower of Pisa. The Eiffel Tower is tipping. The French government decides to reinforce it with wires that extend 100 meters from the base and connect to the top of the tower. The Eiffel Tower is 300 meters tall. If the government is planning on creating 5 reinforcement wires, how much wire should they get? Okay, so basically what we have is, here's our Eiffel Tower. Beep, doom. Looks lovely like that, and it's leaning a little bit. So we've got this going right here, and this length from the base of it is always 100, and it's from the center, 100 meters from the base in the center, and then this length right here is 300. So we're going to end up multiplying this by 5 because we're going to have 5 of these. So this is our wire. So we've got c squared is equal to 100 squared plus 300 squared. So this gives us c squared is equal to 10,000 plus 90,000, which is going to equal basically 100,000. So c squared is equal to 100,000, which means c is equal to the square root of 100,000. So we're going to go ahead and factor out 100,000. So obviously it's just a multiple of 10. So we can do, because if we write it in scientific notation, there are 5 zeros, so this is equal to 10 to the 5th power. So we can say it's equal to the square root of 10 to the 5th. And then we can go ahead and simplify this. So do 5 divided by 2, which is going to give us 10 to the 2nd power because it goes in one whole time with a remainder of 1. So this is equal to 100 square roots of 10, which is approximately, if we put that into our calculator, 100 times the square root of 10 is equal to 3.16 about. So we're talking about 316 meters of wire for just one. And then our final thing is that there's 5 of those, so we have to do 5 times 316, which is going to give us the value of 1,580 meters, or 500 square roots of 10 meters in its exact form. All right, so that's basically just reviewing over 7.3 and then also looking at applications of it using the Pythagorean theorem and simplifying our radicals that way.